Hello guys, let's solve an integral using transformation. So use the appropriate transformation to evaluate this integral where R is the region enclosed by these four lines. Let's plot region R in xy plane first. So in xy plane, so we'll have to use contour plot to plot all these equations in a single graph. So in the list, write all the equations. Twice x minus 3y equals to minus 1, twice x minus 3y equals to 1, 4x plus 5y equals to 1, and 4x plus 5y equals to 5. Take the range of x from minus 5 to 5 and take y from minus 5 to 5 as well. And let's give the axis. And axis label. Also, let's use plot legends. So you can see the small region enclosed by the four lines. Well, let's take x from minus 2 to 2 and y from minus 2 to 2 as well. Then we will be able to see the region better. So you can see that this is the region. So you can also shade the region R. So let's do that. Let's add a semicolon and use region plot. And implicit region. And then we'll have to give the conditions for the region. So if you see the graph, you'll see that twice x minus 3y varies from minus 1 to 1 in the region, and 4x plus 5y goes from 1 to 5. So you can see that the orange one is twice x plus 3y 1 equals to 1, and the blue one is twice x plus 3y equals to minus 1. So you can write minus 1 greater than or equals to sign twice x minus 3y greater than or equals to sign 1, and use double and sign, and then write 1 greater than or equal to sign 4x plus 5y greater than or equals to sign 5. So this way you can define the region R, and x and y are our variables. So this is our region R, and we can just show these two together now. You know how to do that. Just give two variables and use show function. Show a1 comma b1. So you can see the shaded enclosed region in the graph. So this region is in xy plane. Now we will plot the region R, the transformed region R, in the UV plane. So we'll have to use the transformation. So what should be the appropriate transformation here? You can see in the graph that twice x minus 3y varies from minus 1 to 1. So if you say twice x minus 3y equals to u, in the transformed region we'll have two straight lines, u equals to minus 1 and u equals to 1. And also if we said 4x plus 5y equals to v, we'll have another two straight lines in the transformed region, v equals to 1 and v equals to 5. Then it will be easier for us to set the limits of uv. So limits of u will be from minus 1 to 1, and limits of v will be from 1 to 5. But to find the Jacobian, I need x and y in terms of uv, because I have to find the Jacobian of uv. So solve these two equations. Solve twice x minus 3y equals to u, and v equals to 4x plus 5y. And I want to know x and y from this. So these are our x and y. So let's define x and y first, then I'll be able to find the Jacobian easily. So define x equals to 1 by 22 5u plus 3v, and y equals to 1 by 11 v minus 2u. Now before finding the Jacobian, let's just plot our region in UV plane. So let's just copy paste all these commands. Let's just copy paste all these comments here and change the variables as a2 and b2. Now as we have defined x and y, Mathematica will substitute the value of x and y in the comments. So these equations inside contour plot are now in terms of u and v, because we have defined x and y in terms of u and v. So let's just change the variables from x and y to u and v now. Same with the implicit region. So the variables are now u and v. So if we press shift enter now, we will get the same region but in UV plane. So I have to show A2 and B2 now. Well, we need to fix the range of variables. We don't need the plot legends here because all are straight lines. So let's take u from 0 to 4. So v is greater than 1 in the region. So you can take v from 0 to 4. Well, I changed the range of u. So v should be from 0 to 4. And keep u from minus 2 to 2. Well, v is bigger than 4, so let's take 8. So you can see the enclosed region in UV plane now. So this is the same region R but transformed R in UV plane. Now as we have defined x and y already, we can easily find Jacobian now. Before doing that, let's take v from minus 1 to 8 because I want to see the u-axis. U-axis is not visible in the graph. So now it's visible. This is the u-axis. So v goes from 1 to 5 and u goes from minus 1 to 1. Now, as we have already defined x and y, we can easily find the Jacobian. So let's write a variable, set a variable, Jac equals to the Jacobian. So the partial derivative sign and xy inside the curly braces, and then give double curly braces and write uv. Then we have to give the determinant comment. So write det with capital D and keep the whole thing inside the square bracket. So the Jacobian for our transformation is 1 by 22. Now you can do the integral. Just replace dx dy with 1 by 22 du dv. So write the integral sign for double integral. And u and v are our variables. And the expression is twice x minus 3y divided by 4x plus 5y. Now we can write u by v here because we are integrating with respect to u and v. But as we have already defined the x and y, so you can just simply write twice x minus 3y, 4x plus 5y. So Mathematica will substitute the value of x and y here. Now let's multiply Jacobian. So we have set a variable for the Jacobian. So write the variable. Now u goes from minus 1 to 1 and v goes from 1 to 5 in the graph. So the limit for u is from minus 1 to 1. And v goes from 1 to 5. So if you press shift enter now, we'll get the output. So the result is 0. So we have set an appropriate transformation for this integral and solve this integral using that transformation. Now let's look at another problem. Here and the transformation is given. Use this transformation u equals to x minus y, v equals to x plus y to evaluate this integral where R is the region enclosed by these vertices. So 1 0, 2 0, 0 minus 2 and 0 minus 1. There is an easy way to plot this region R. Write line command and inside the command give a list and close the list, and inside that list give separate lists for this coordinates 1 0 and keep that 1 0 in a list, and then give a comma and write 2 0 in another list, and this way write all the lists. Zero minus 2 and 0 minus 1. And keep the whole thing in graphics command to plot this. So you can see that there are 3 lines actually. So if you see the coordinates, you can see that this point is 0 minus 2 and this point is 0 minus 1. So this is the y-axis. So this point is 1 0. Then we connected 1 0 with 2 0. Then we connected 2 0 with 0 minus 2. Then we connected 0 minus 2 with 0 minus 1. Then at the end we will also have to connect 0 minus 1 with 1 0. So add comma and 1 0. So this will complete the region. So you can see the region now in the xy plane. So inside the line command write the coordinates one by one to connect the coordinates. Now we have the transformation u and v in terms of x and y, but we need x and y in terms of u and v. Let's delete the variables first from the previous problem. So let's find x and y in terms of u and v. So this is our x and y. X is u plus v by 2 and y is v minus u by 2. So let's define x and y. Now to plot the regions in UV plane, we need the lines, we need the equations of lines in the UV plane. So you have to find the equations of lines, these lines in UV plane. Let's write the formula of equation of lines from 2 points. So y minus y1 divided by x minus x1 double equals to, I will write double equal because I will solve these equations, and then write y2 minus y1 divided by x2 minus x1. Now I want the equation of lines in UV plane, so I'll solve this equation and find the equation in terms of u and v. So say I want to know v, so give a comma and write v. Say x1 y1 is 1 0 and x2 y2 is 2 0. I want to find the line connecting these 2 points in UV plane. So I'll solve this equation and find say v in terms of u using this equation. So let's keep this equation inside solve, and as we've already defined x and y, so the equations have already u and v in it, because y and x will be substituted by the expressions. And I want to know say v or u, so write v now, and let's replace x1 and y1 with 1 0 because 1 0 is the first point. Let's just copy paste all these coordinates so that I don't have to come here every time. So first you have to connect 1 0 and 2 0. So x1 y1 is 1 0 and x2 y2 is 2 0. So we have replaced the values of x1 y1 and x2 y2. Also we have x and y in terms of u and v in the equation. So if we solve this equation, I can easily get the expression for v in terms of u. So that will be the line connecting 1 0 and 2 0. Also let's use simplify here to get the simplified version of the equation. So if we press shift enter now, u equals to v. This is the equation of the line in UV plane connecting the 2 points 1 0 and 2 0. As we want to plot the region R in UV plane, so inside the contour plot, let's write u equals to v. This is our first equation. Now change the x1 y1 and x2 y2. We now want to connect 2 0 to 0 minus 2, but we get v equals to complex infinity. That means the equation here does not depend on v, so we can find u from this equation. So let's find u. See, u equals to 2. That is why we didn't get v. So if you don't get v, try to find u from the equation. So u equals to 2, and then connect 0 minus 2 with 0 minus 1. So u equals to minus v. And lastly, we'll have to connect 0 minus 1 with 1 0. So u equals to 1. And then give a range for u and v. Take u from minus 5 to 5 and v from minus 5 to 5 as well. Let's take the axis and axis label. Also, let's take the plot legends. So you can see the bounded region there, two straight line and two lines, u equals to v and u equals to minus v. You can change the range a bit to see the region better. So this particular region in xy plane has been transformed into this region. As we have got two straight lines now, we can easily find the limits. As you can see that u goes from 1 to 2 and v goes from minus u to u. So let's take u from 0 to 4 and v from minus 4 to 4. So you can see the bounded region better now. Now let's just shade the region. So let's take B1 region plot, and inside the implicit region you can just write the expression in terms of u and v now. So u goes from 1 to 2 and v goes from minus u to u. You have to give double end sign, not comma. And u and v are our variables here. And show a1 b1. Well, I didn't give the semicolon sign in contour plot. Now you can see the shaded bounded region inside the graph. So we have already defined x and y in terms of u and v. So let's find Jacobian. So the variable jac equals to partial derivative sign xy and give double curly braces, and inside double curly braces write uv, and I will have to find the determinant of this. So write determinant det with capital D and keep the whole thing inside the square bracket. So the determinant is half. So Jacobian of the transformation is half. Now write the double integral sign. So limits of u are constants. So we'll have to integrate with respect to u later. First you have to integrate with respect to v. So dv first, because v goes from minus u to u, and then we'll integrate with respect to u. So v goes from minus u to u, and u goes from 1 to 2. And the expression is e to the power x plus y divided e to the power x minus y divided by x plus y. And we have to multiply the Jacobian. So the output is in complex. I think the expression should be to the power x plus y divided by x minus y. Let's take the numerical value. You can see that this has I component, the imaginary component. Let's change the expression to e to the power x plus y divided by x minus y. So if we integrate e to the power x plus y divided by x minus y, let's see what do we get. So we get something in real.